Hello, this is Jack Jackson. This is the start of our third playlist, Unit 3 or Chapter 3 of my college geometry class. Here's my latest version of the notes, and they're hyperlinked. The zero section is Introduction Course Policies. In the first week, we looked at Introduction, Early History, and Foundations of an Axiomatic System. Looked at some different sets of postulates there. And then last week or last chapter, last playlist, we looked at some incidence geometries. This is incidence properties, and this led us to look at some finite geometries as examples there. And so we did our earliest proofs of our earliest sets of postulates in our formal development of unified geometry. This week, we're going to look at distance, order, between, and we're going to introduce our four main infinite geometries that we're going to be looking at throughout the rest of the semester, at least most of the rest of the semester. You may notice that each week there's a sort of a theme, even though all this material is cumulative as we go through, there is a theme, and that's the theme of this week is distance, order, between, and then these finite geometries. So here are some of the topics that we're going to be looking at. We're gonna talk about distance and order, look at Hilbert's postulates of order, and then the measurement of distance. We'll talk about Birkhoff's properties or postulates of distance, and we'll get to that in a bit. Before that, we'll do some informal looking at um, distance. So what I like to do in most of these notes is explore concepts informally, something like you might even do in a maybe middle school classroom or the first part of a high school geometry class. And then from there, we go to our more formal approach. Again, we're going to be looking at our four infinite geometries. That's Euclidean, taxicab, spherical, and hyperbolic geometry. We'll look at seeing those and illustrating those in GeoGebra. And then we'll go ahead and get the formal approach there. So let's go ahead and get started. Okay. Um, let's start here with distance and order. So again, this week we're going to be talking about concepts of order, between, measurement, and distance. So in a purely synthetic approach to geometry, like Hilbert's development, or somewhat even Euclid's development, the term between is taken as an undefined term. Now we certainly have some intuitive idea of the meaning of between in geometry, the point being between two other points. But Hilbert left the term between actually undefined. But how, of course, how do you give meaning to undefined terms? You have some postulates. And so there are four postulates in this section 2 of Hilbert's postulates on order. Let's run over those real fast. And these are going to be actually propositions in our formal treatment of geometry. So Hilbert's postulate 2.1, if a point B lies between a point A and a point C, then the points A, B, and C are three distinct points of a line, and then B also lies between C and A. Okay, postulate 2.2, for 2 points A and C, there always exists at least one point B on the line AC, such that C lies between A and B. Postulate 2.3, of any 3 points on a line, there exists no more than one that lies between the other two. Postulate 2.4, let A, B, and C be 3 points that do not lie on a line, and let a line be in the plane ABC, which does not meet any of the points A, B, and C. If the line A passes through a point of the segment AB, it also passes through a point of line segment AC or through a point of the line segment BC. So you should be able to stop for a minute here and just think about this. And using what you already know about Euclidean geometry, you should be able to convince yourself that these are true in your intuitive sense of what we mean by between. Okay, so I'll let you think about that on your own a bit. And then what we do with Hilbert's postulates then is we prove other postulates of other propositions about order using these as postulates. Okay, and really in a purely strictly synthetic approach to geometry, the concept of measurement, distance, and angles then are all put off as long as possible. And really the only numerical properties that we assume are properties of rational numbers. And then Hilbert was able to then rigorously prove the propositions of Euclidean geometry systematically and synthetically. And then ultimately you can use that geometry postulates to prove properties about real numbers, which can be derived from geometry. And there's certainly a very much a great beauty to this approach. And I encourage you to maybe actually read Hilbert's book on geometry at some point. However, there's also an advantage of introducing analytic concepts of distance and angle measure a lot earlier, like in this unit, in this week's work. Um, so we could use Hilbert's approach to prove additional properties related to the concept of between, but these proofs are somewhat difficult and they can be made easier with the introduction of a distance metric. And introducing a distance metric at this point has the advantage of speeding up our development of unified geometry a bit. But in addition to making proofs easier and speeding up our development, there's other reasons for introducing the measurement at this point. The concept of measurement, including distance measures, is fundamental to the study of K-12 geometry. It has important applications in our world, also in courses like pre-calculus, calculus, and so forth. And because of these reasons, we will take a hybrid approach by introducing a distance metric this week to our study of unified geometry. And once these appropriate formal definitions and postulates are added, we will then be able to define the term between, and we will then prove Hilbert's statements above, making them propositions instead of postulates. And from that point on, the subsequent propositions could either be proved in the Hilbert manner using his statements, which would now be propositions instead of postulates, or they might be proved using the analytic properties of the distance metric in a manner to our proofs of Hilbert's, what were his postulates, but will now be our propositions. And we will typically take whichever route is easier. So we're going to introduce a concept of a distance metric and a coordinate system for a line. And those will give us some formal concepts that we can go for and look at and study. But before we do that, in our next video, we're going to informally talk a little bit about distance measures.